Okay, we are given the diagram. They say a circle is inscribed in a square of side 1 cm. And I ask, what is the area of this circle? Okay, there is a way I will solve this by using the relationship connecting the radius of this circle and the side of the square. So let the radius be r and side x. So there's a relationship connecting the two, that the radius of this circle is always root 2 minus 1 all squared times x, which is the side of this square. So what I will do, I will just solve this with this relationship. After, I will prove how I got this. Okay, from here they say the side is 1, so the radius is root 2 minus 1 squared. X is 1. Therefore, the area. Okay, let's just finish up this. This is 3 minus 2 root 2. So that's the radius of this circle. So to calculate the area is pi r root squared, which is pi times 3 minus 2 root 2 all squared, which is 9 plus 8, 17, minus 2 times 4, 12, root 2 times pi. So that's our answer. So our answer is option A. So let me now prove how I got this relationship. Okay, look at this. That same diagram, they say a circle is describing as what is the radius of the circle in terms of the side of the square. Okay, let the radius be r and the side be x. Let me add some of the auxiliary lines. Okay, let's call here O, A, B, C, and here D, maybe E, F, G. You can see that from this, if you look at this, this is you can see that this is a square now. This is G, B, E, and F. So you see that if the radius of this circle, let's call it R, you see that EF is R. So they are all R, R, R. So here is R. This R, 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 R. So this is the diagonal. The diagonal using the what we call, this is 90. As you can see, this is 90. So using 45, this is an isosceles triangle, 45, 45, 90 triangle theorem. You see that the diagonal FB is R root 2. So this is R root 2. As you can see, FD is also the radius of this circle. So this is R. And as you can see, we have something like a circle. This is a quarter circle. So if the side is X, here is X, OD is also X. Like this is a sector. So this is the radius, which is X, which is the same as the side of this square. So what do you have to do? This is X, this is R, and this is R root 2. And these are OB is the diagonal of the big square. So you can easily see that OB is equal to OD plus DF plus FB. Yes. which is OB. This diagonal using, this it is 90. This angle 90. So this is a triangle BCO. So using 45, this is also X. That's this length is X. Using 45, 90 triangle theory, you see that OB is also X times root 2. So OB is X times root 2. That's the length of this diagonal. We'll call it 45, 90 triangle theory. As if you have a triangle that the sides are the same, that's an isosceles right triangle. If here is X, here is X, here is X times root 2. That's what I used here. And that's what I used here too. OD is X plus R times root 2. So let's look for R in terms of X. Let's make, from this you can see that here moving X to this side, so we have X root 2 minus 1. Y here, bring out R root 2 plus 1. Solving for R is now X times root 2 minus 1 over root 2 plus 1. And if you rationalize this, multiplying by the conjugate of this, which is root 2 minus 1, we have X root 2 minus 1 squared. So that's it. That's our radius, which is, if you expand this is the same as 3 minus 2 root 2 X. So that's the radius of this circle. That's why I use this first. So that's how I got A. Thank you.